All right. Hello. Hi there. Welcome to the stream. This is my first time streaming, so apologize if anything breaks down. I'm going to be trying to do a couple of streams on things that I do as a graduate student. I'm a PhD student at Brown, and this stream will be about porting a Python script, a simple Python script that I've written for one of the courses that I'm helping to teach at Brown, porting it to a language called Rust. The reasons for this are partially because I want to practice writing Rust because I'm relatively new to it, but also because the script has been running in a particular way for, I'll explain in a second what it's about. But it's been breaking down every now and then, and so I thought this might be a good opportunity to show the features of Rust in terms of making certain ways of thinking about the software more available to the programmer, such that you can handle error cases in a more particular kind of way. So yeah, let's get started. I'll explain the script and the kind of problem, and then we'll get into writing some Rust code. And it should take maybe 2 hours, maybe 3 hours. I'm not sure. I haven't written Rust in a while. As I said, I'm relatively new to the language in general, so this is probably best for a beginner audience. If you've written a bit of Rust, if you kind of understand what it is as a language, but you are not so familiar with it, this might be interesting to you in order to work out how you can write things in Rust and how they can work, especially if you're familiar with other languages like Python, but you don't necessarily need to have experience with Python in order to follow along the stream, or at least I wouldn't have thought so. So let's get into it. So this is the course that I'm helping to teach at the moment. It's in the computer science department at Brown. It's called Database Management Systems. The script that I have in relation to this course is because of one of the ways that students are able to ask questions when they're working on assignments in the course. So many Brown computer science courses use this platform called EdStem or Ed. And EdStem is basically a message board system where instructors, TAs, and students can all be on this message board. Students can post questions on the message board, and they can set them to either public or private, and then TAs can respond accordingly. So in this case, we have some posts that are announcements from the course instructor, Ursa and Temel. Students can respond, but there are also some cases here where there are more private questions that are specific to a particular implementation of an assignment or something along these lines. So a new one's just arrived here, for example. In order to manage this from the instructor and TA perspective, we have decided, in this course at least, to use a spreadsheet basically to track what's going on in EdStem. So EdStem's pretty good. You can do things like filtering by unread or filtering by unresolved, which are sort of slightly different notions of the status of a question. I believe that unread means I've never looked at the post, whereas unresolved means I might have looked at the post, a TA might have responded, but if there's a follow-up from a student, then it will be unresolved. So one can track all of these things in EdStem, but there's a couple of things we wanted to do as a course staff that weren't really feasible within EdStem, or at least weren't immediately feasible. So we decided the best way to do this would be to use just a spreadsheet. The spreadsheet, the main tab in the spreadsheet is a set of rows where each row has a EdStem post or corresponds to an EdStem post, and I can click on this URL and go directly to that EdStem post, for example. And then we can basically create new columns and customize the spreadsheet however we want in order to keep track internally as a course staff of what the status of these questions are. So the main way that we're using it at the moment is to sort of delegate unresolved questions or new questions to different TAs. We've set the sheet up in such a way that, for example, if I go to this post here and I see that there's a question here, it may have already been answered. So in this case, for example, a TA has already answered this question. So I could just put assigned to Shirley, who answered this question. And then I just make a note of who did the triaging here as well. And the sheet is set up in a way that this will come into Shirley's personal tab. And because Shirley's already answered this question, I'm just gonna mark it as answered here. But this is basically the way that this sheet works. Is we have new questions. These questions we want to assign to different TAs, and then the TAs can answer in the ways that make sense on these questions. So in this case, for example, there is a setup question that I haven't responded to, and this has been assigned to me and I need to respond to it. So the purpose of this stream isn't to respond to these questions, it's to rewrite a script that is working to make the spreadsheet work, which I'll go over in probably now. So the spreadsheet is being synced with EdStem. This is the kind of key critical component via a script. That basically the script goes to EdStem, it's connected to the Google Sheet as well, and it pulls all of the posts from EdStem, it checks all of the rows in this tab in the spreadsheet, and it will add any rows, add any questions that don't exist yet in the spreadsheet as rows here. And the way that this works, I'm going to go into a little bit of detail because this will be the bulk of what I'm talking about in the stream. So there's a row that's column that's normally hidden here called IDs. This ID here corresponds to a question on EdStem, and this cell here you can see is just an expression which templates that ID into the URL template for EdStem posts. So there's a variable here called course ID, which is, I believe, in a maybe hidden sheet, or sorry, this sheet here. So I'm just using this as a kind of global variable in Google Spreadsheets because our course is always the same. So I put that course ID there, and then I reference the cell, A3, or in this case, A4, A5, so on, in order to create this URL so that I can get directly to the question post from the spreadsheet. So what the script actually does is it checks these IDs and adds any new IDs down the bottom here that don't yet exist. And we're relying here on EdStem creating a unique ID for every single post, but that is something, thankfully, that EdStem seems to do. So this is the kind of problem that I'm trying to work with, and just to go into a little bit more detail about why I want to rewrite the script in Rust. So the script is currently a script that exists in Python, and it runs in a loop. So it queries all of the questions from EdStem, it queries all of the rows in this tab from the spreadsheet, and it works out what the ones that it needs to add are and adds them to the sheet, and it does this at some sort of interval. So I think the interval is 60 seconds at the moment. So it will run, complete its running, then it will sleep for 60 seconds basically, and then in 60 seconds it will start up again and try to run again. And this is fine, we don't need a faster refresh rate for the way that we are working with the questions. But the issue is that the Python script seems to sometimes just stop running. It seems to break. And when you look at the net, may have dropped out for a second there. Where was I? The script. So yeah, the script is working in general, or it works when it works, but it doesn't work when it doesn't work. And when it doesn't work is when it's running for a couple of hours, or it's running for a long period of time. And if it tries to query the questions from EdSTEM in a particular way where it's not able to for one reason or another, maybe the internet connection on the machine that the script is running is not very good, maybe the EdSTEM API goes down for a moment or is rate limited or something along these lines, there's some sort of interruption, and the script that I have at the moment has no error handling to deal with when there is this interruption. So the obvious solution here would be to improve the script so that it handles errors appropriately, and one could very well do that, but I thought it would be a good opportunity to practice writing some Rust for me, and also show the kind of reasons that you might want to rewrite a script from Python to Rust, and try to explain some of the things that I currently understand about Rust, why writing in Rust for this kind of thing, for this sort of systems related thing where there are a couple of error cases, is a really nice thing to do, and is much better, I would argue, than writing such a script in Python. So let me get started on first just showing you the way that the current script works in Python, and then I will basically code this new script in Rust from scratch, and I may have to look up some things, hopefully not too many, but it shouldn't be too complicated because it's a relatively straightforward script. So this is the Python code that I've written, and the details of everything that's going on here aren't super important, as in if you don't understand exactly what the Python syntax means, don't worry too much. I'm just going to go over it at a high level. So the sheet uses a bunch of different libraries. The script, sorry, uses a bunch of different libraries. And instead of passing command line arguments or anything like this, I've just set these as global variables in the script. The course ID defaults to the actual course ID of the course I'm interested in, but I've got this kind of hacky way of passing it as an environment variable if I need to as well. The same with the worksheet name. The Google Sheet ID, I decided obviously that I didn't even need that, and I've just hard-coded the Google Sheet ID. The service account credentials, which are required because the script needs to be able to access both to read and to write the Google Sheet, and so you need to create what in Google Cloud, I think it is called a service account, in order to allow the script to read and write from that sheet. And I also have a poll rate. The poll rate is what I was talking about before, where it runs this operation, adding new posts to the Google Sheet at some sort of interval, and this poll rate is, if I remember correctly, in seconds. So this is specifying that every 60 seconds I should try to refresh the sheet. I'm also using this ed API repo that exists. I could actually probably bring it up here if I can find it. It is this is the wrong one, sorry. Elite Dangerous API, that's not the right thing. This looks right, I think. Yeah. So this is a package that someone has made, which is an unofficial integration of the id API with Python. And because my script is in Python, I can just make use of this in order to query the id API to get some things. In the Rust version, I have two choices. I could either just sort of hard code the HTTP calls in, or I could kind of write my own version of the this package, but in Rust, a wrapper around the API calls. I guess there's a third option where I could try to do some sort of FFI, which is foreign function interface, to call the id API library or something like this, but I wouldn't want to do that because then I'd have to have a Python environment and this kind of thing in my Rust script as well, so that's not really an option. So I'll work this out as I go. I'll probably do some sort of thing in between those two options, which is to make a kind of layer of the Rust script that is a partial implementation of the id API just for the calls that I need. Okay, so going back to the script. So in the script's logic, I first have to log in, authenticate to idstem. Then I have a bunch of these functions, and the main loop of the script is here, which is while true, try to sync the IDs, the thread IDs, to the sheet. Idstem refers to questions, I believe, as threads. So each of those IDs here is a thread ID. And then I basically sleep for the amount of time of the poll rate. I'm not going to go into the detail of how exactly these things work, because we'll go over it as we work through the Rust application, I think. Okay, so let me get started on rewriting this as a Rust script. So I'm going to create a new project, which is not going to be called, no, it will be called idstem sync. I'm just going to call, so the old Python repo that I had was called idstem sync. It's not a great name, but it's somewhat descriptive. So I'm going to create a new bin that's idstem sync. And I'm just going to do a cargo run to make sure everything's okay with Rust on my system. Hello world seems to be working. Okay, so this is the default Rust application. And let me just get rid of that transparency. Okay, so the first thing I need to work out is not how I will do the idstem API, because as I mentioned, I'm going to have to write that myself, but how I am going to authenticate to Google Sheets. So luckily there's already a Rust crate for this, which is called Google Sheets 4. I've used this before in a couple of scripts, so I know that it works. It might not be the only way to interface with Google Sheets, but I'm fairly sure it works. Okay, so it says here that in order to add this as a dependency, I add this to my cargo toml file, and I also add these two crates, surday and surday.json. I believe this is because the Google Sheets crate uses both of these libraries as their serialization, deserialization logic. So I'm going to add those to my library here, and I'm just going to create a new terminal get into my Rust project here and run cargo run. Okay. So cargo run will check cargo toml, I guess, and install any libraries that it needs, which is now some of these things. While that's installing, let me think. The other things that I will need are some way of passing command line arguments potentially, but I'm going to worry about that later. And this should be all that I need. Let's look through this example, and then I think I'm going to realize that I need some additional things potentially. So this is a complete example of using the Google Sheets grid. It gets application secret by some means. Okay, so this is the way that it authenticates. I'm going to want to authenticate with a service account because I already have that service account, those service account credentials in a JSON file. So I'll work that out shortly. And then it uses the sheets.new. And in this case, it seems to use the create hyper. So hyper is a fast and correct HTTP implementation written in for Rust. So one of the interesting things for me about Rust is that it doesn't build a lot of kind of straightforward things into its standard library. It sometimes requires you to use crates and make a decision about what kind of code you want to use in order to do something like making an HTTP connection. This is not entirely true. I think there is a mechanism in the standard library for making HTTP requests, but the standard way to kind of do it in a secure application, I guess, is to use something like Hyper as your HTTP implementation. So they've written some extra code around the standard library code, I guess. So I think I'm going to use Hyper because it seems like a reasonable thing to do. In order to do that, I'm going to add it here. There was also this Hyper Rust ls. I do not know what this is. A pure Rust HTTPS connector for Hyper based on Rust ls. Modern TLS library written in Rust. So my guess is that the standard library and maybe Hyper relies on some sort of system calls, some operating system calls in order to make like a TCP connection or something, whereas this is a re-implementation of it in some kind of way. Do I want to use this? I think I'm going to, just because the example here uses it. Let's try without it, and then if it becomes obvious that I need it to pass in there, and I can't do something else reasonable, then I'll bring it in. Okay. So we're all installed with these libraries, and now what I'm going to do is just try to code some of this in. There's a renaming here of, sorry, I just got new keyboard bindings, so I need to make sure I know what I'm doing. Renames it to sheets 4, and then it uses some of these sheets for values. Probably don't need all of these, but let's just bring them in to begin with. And here we go. Okay, so it looks like the way to get started with this is to construct a hub. And I'm going to need to pass some auth into the hub. Let me work out what a hub is. The API is structured into the following primary elements: hub, a central object to maintain state and allow accessing to all activities. Okay. Creates methods builders, which in turn allow access to individual call builders. So it builds a hyperclient with this value of hyperrust_ls, and it uses the hyperclient with the sheets.new function. So let me look into what exactly that sheets.new takes in. So it takes in specifically a hyperclient, okay? And okay, so I definitely need hyper, which I have. Just to make things easier, I'm going to add hyperrust_ls as well. I'm not super sure what the trade-offs in doing this are, but that's okay. I could always look into it later. So hyperrust_ls. Sometimes there's a thing with, yeah. Did I find it? Yeah, so these are errors from the running of the script. Sometimes there's a thing with Rust crates where they expect to be done, even though it says, it seems here that it's got an underscore, it's actually got a hyphen in the cargo package listing or something. So I've added that there. If I reload, okay, so it's not giving me an error here anymore because I have hyperrust_ls, and I can run all of these things. I can set up that hyperclient, but I do not have an auth. this auth in the example here is, okay, so this is where I'm going to go back to the sheets.new, and auth here is an A, where A is a static plus client get token. I'm not familiar enough with the Rust syntax to know exactly what that type signature means. Static is a lifetime, which means that the duration of A must live for the whole program. Maybe the plus just means this is the lifetime and this is the type, and the type here is client get token. So, okay, this is in Google APIs common, and get token. I need some sort of Google APIs common. Let me just double check that. Yeah, so Google Sheets, this Google Sheets for crate must be using the Google APIs common crate. So this is just what we're looking at now is just the local code on my computer. But I can kind of, because I've set up my editor in such a way that it has code intelligence, I can go to where this get token is coming from and then look at where it's coming from. So this get token type is coming from client. Oh, and client is a hyper client. Okay, so it's actually a hyper client get token. No, maybe it's not a hyper client. Auth. Okay, this is a re-export, sorry, of auth get token. So, I mean, just to state the problem, what I'm trying to work out here is I obviously want to pass an auth, but the example here uses OAuth 2. I don't think I want this auth. I want an auth that uses a service account local file. Oh, here's the actual type of that. There's a box of a didn't get token. The OAuth 2 in this example is coming from Sheets 4. It's a re-export of auth. Okay, so one thing I can do is check one of my other so this is another application that I wrote, I think using the same library, and okay, this is kind of this is what I did. So the auth here uses the OAuth 2 from yeah, from sheets 4 up here. But there is a way to use the service count key, and it says sets up the secret and then, okay, returns a service count authenticator there. So I can do that. Let auth equal, and let me write a function called get auth. Sorry, as you can see, I just got new keyboard bindings, and so I'm getting used to them. Okay, so this auth function is going to be quite similar to this one. In this case, it takes in a client because it instruct the new authenticator that uses the installed flow in the provided HTTP client, because it needs an HTTP client in order to authenticate itself. I see. Okay, so I'm actually just going to copy this entire function to begin with, and then we'll see what the issues are. Cannot find type args. That's fair. So in this case, and I am going to copy this pattern, it uses a args struct that has some details on it. And because I want to make this script more robust and better in general, I am going to eventually pass in command line arguments. So I'm going to do that work now, which is to set up a struct that is args, and I want the same kind of thing here, the service count path on the struct. Syntax error, expected type. The type here is going to be a string, I think. Okay. So there are two types of string in Rust. The reason that I hesitated is because string with a capital S means it's a string on the heap, I believe, whereas string like this, @stra, is a reference to a string, so a pointer to a string. There might be more, slightly more complicated, slightly more subtle than that. But if I had done @string here, it's going to start giving me these errors like consider missing lifetime specifier, expect a lifetime parameter, because the @stra here is saying that this is a reference to a string, so the string must live somewhere else. And this struct, therefore, the legitimacy of this pointer relies on the struct's lifetime as well. So I need to start introducing basically like lifetime parameters into the arg struct in order to make the compiler check out. So this is one of the kind of frustrating things about Rust for many new people, but actually really important in terms of what Rust can provide you in terms of writing more secure code and safer code, is that it tracks the lifetime, the compiler, when I say it, I mean the compiler, tracks the lifetime of variables that you define. And if you pass that variable around, as in if you pass a pointer into a function, it will only allow you to do certain things with that pointer depending on what the specified lifetime of that pointer is. So this can be really annoying if you just think about variables as, you know, pointed to some sort of data, but it actually is a way that Rust forces you to be more specific and think more carefully about how your lifetime is, how your data is being instantiated, where it's being stored, and when you can get rid of it and where you can keep it. The reason, in short, that Rust needs to have these kinds of lifetime issues or compiler errors is because Rust has no garbage collector. So it's one of the kind of necessary additional features of the language to allow you to write secure code, safe code, and it's one of the reasons that Rust is preferred by many to a language like C, which also doesn't have a garbage collector, but doesn't do anything in terms of tracking how the lifetime of your pointers are working, and this can lead to some really gnarly errors, as anyone who has programmed in C will probably know. So long story short, I'm just going to put a capital S string there, which means that this string lives on the heap and therefore can kind of be, I think it's correct to say that it can be owned, or it is owned by the struct args. Okay, so we're still getting an error here. Cannot find type authenticator. It's true because authenticator is coming from sheets for auth authenticator, I believe. Unresolved input. Okay, it's not coming from there. It's coming from sheets OAuth to authenticator. And it's telling me I don't need the self here. And yeah, it's going to get rid of this. I'm not yet using those because this was me partially coming through the example. Okay, so now making progress here. Get auth. This should be getting better, but okay, so this is kind of an interesting error. My get auth function, because I copied it from the other application, I declared it as an async function, which means that this function call is, what's the language that I want to use here? It returns something in Rust called a future, which is why this type signature here is saying the auth variable here is a impl future output equals authenticator. A future is basically code that hasn't yet been executed or potentially hasn't yet been executed. Async Rust is important, but is it something that I want to do here? Yeah, I think it is something that I want to do here. So let's work through it. So the way that this is back to my my other application in which I'm using this thing here, the Google Sheets API. You can see in this application, when I call letAuth, I say letAuth.await. And the .await here basically says ensure that you execute this code before you return it, and you can see the type that auth returns there is not a future or not an impl future, but a different kind of type. So this is going to introduce a different set of problems, but if I do .await here, then you can see the type of auth becomes no longer a future. It's a straight up authenticator, and the error here is no longer coming in down here, because this is now the legitimate type. I'm getting another error, and the reason for that is Yes, that's what I thought. So await is only allowed inside async functions and blocks. This code is being called, the await is being called inside an fn main that has not been declared as asynchronous. That actually gives me a nice error here that says this is not async. So in order to call this asynchronous code, in order to use this kind of asynchronous Rust, or to use this idea of a future, I need to make my whole application specify that, tell the Rust compiler that it's an async application. It may be possible. Yeah, that's what I thought. So there's some sort of continuous work being done by like an async working group or something, changing various parts of Rust to make it more easy to operate with async and this kind of thing. That's why I tried to see if I could just annotate this here. I don't know enough about the specifics of how this is working to say whether that's a good idea or whether that will be available or anything. But the idiomatic way basically to make the main function into async at the moment is, let me just change back to my other application here, data sheets, is to annotate it with Tokyo main. And Tokyo is a library that is basically allows you to write async Rust. I'm just going to use it here. Without going too much into the details. Partially because I don't actually really know them. There's something around the way that async function invocation works, and being able to pass around blocks of executable code that requires you to kind of tell the Rust compiler that if you use any kind of asynchronous functions, then you need to tell the Rust compiler that the main function is also async. And there are some specific reasons why you can't do that by just saying async. Let's actually see what they are. It might, if I just do this, maybe it will yeah, it just tells me main function is not allowed to be async, but I can make the main function async if I annotate it with Tokyo main. And now it doesn't give me the error. And Tokyo main, I think, does some kind of, yeah, it's a macro. So a macro basically allows you to like rewrite the code that comes next. Macro on Rust, this allows you to rewrite the code that comes next, and before it tries to compile it, it replaces anything that you say in the macro. So this macro is basically doing something with the main function that allows it to get around the compiler errors. And this means that I can then call asynchronous functions like getAuth from within my main body. I'm still getting an error here. GetAuth. This function takes 2 arguments, but 0 is supplied. This is again because I copied the, this from here, but I think I want to keep these 2 arguments. So getAuth, as I copied it from the other application, takes an args argument, which is basically the specification of the service account path. I could have just passed the service account path here because I don't think I need the args for any other reason. But I'm going to pass the args because this is basically the this arg struct here is going to represent the configuration that I want to pass into the through the whole script or through the whole application. And you can see that args here is an at args rather than just a args. And this means that it's a reference to this args struct. So I instantiate the struct once. I say, here's all my configuration. Up the top of this main, I'll do it. And then I can just pass it in as a pointer to these other functions that need to make use of the values that are within it. So the first argument I need to pass is args. So I need to actually create the args so that I can pass it. Let args equal args service account path is going to be /service account JSON, and it's giving me an error here related to that string issue that I was talking about. So this specification is not a string on the stack, I believe. So to bring it to the stack, I need to use this toString helper method. I could be wrong here, but I believe that if I do service account path like this, yeah, it tells me expected string but found at string. So I think that this kind of specification of a string puts it on the stack. I think I've been using these words maybe wrongly, but it puts it on the function stack, which is not the same as the heap, where the heap can be used out of the context of the function stack. So this puts it on the function stack, which means that it is basically treated as a @str, which means a reference to that place on the stack is passed around. If I want to put it on the heap instead, so that I can use it as part of the struct, then I have to call this toString. Okay, then I need to pass the reference to args into getAuth. And the other thing I need here is a hyperclient, which is, yeah, basically I'm pretty sure that what this client does. Just going to restart my editor because I'm getting some issues with the code intelligence. Oh, still getting some issues. It's not good. That one seems okay. Not sure what's going on here. Okay, seems to be working again. Maybe not. Yeah. Where was I? So yeah, so this client is the same, and I only need one client across the application, but the sheets, there we go, now it's back. The sheets new doesn't take a reference to a client. It needs to take ownership of the actual client in there. So what I wanted to do is take this client out, construct it up here, and then pass the reference to the client in here, which, let me do that to just show you what the error is. So if I create the client up here, equals hyperclient this method takes, oh, I think I didn't copy the right code here. Sorry, I missed this. Yeah. And this is supposed to be this, and now it's all good. So if I put this out like this, then this is the right type for what I need to pass into here. It's a client HTTPS connector, HTTP connector, and this takes a client HTTPS connector, HTTP connector. So this is right. This client is also not a reference to the client. So I could look into why that is, but it's not that critically important for me right now to optimize the memory of the memory use of this application, in the sense that the reason I would want this to be a reference to a hyperclient rather than a hyperclient itself is because it's much cheaper to pass a pointer into this function rather than passing the whole thing into the function, because the function call stack needs to create that as a local variable, copy it over to the local variable, do something along those lines. The way to create another copy basically of this, if I'm comfortable just saying I don't really mind right now if there's a little bit of extra memory used, so I'm just going to try to copy this object that I already have here, copy this client into here, so that this function getAuth can take ownership of the client. I can do that just by cloning the client. This is the way that you do it in Rust. So if I do, client.clone, clone creates a new client that has all the same settings as the existing client. So yeah, this is effectively, I don't actually know if it's exactly the same as just creating another client here exactly in this way, because you can see in the clone, it just clones all of the inside settings as well. So we'd have to like keep going down and see if that clone is actually doing extra work, or if it's just the same as the constructor, to work out whether that work is exactly the same. But as I said, my goal here is not to really optimize the memory use of this application, at least not at this stage. So I'm just going to clone it in there, and I'm going to do the same thing here. The client is the first argument. So client.clone. Okay. Rust Analyzer is not the one I run. Still getting one error which says private type args declared in public interface. And this is because I have declared this function as a public function and this function as by default private. So for the time being, I don't need any functions to be public. So I'm just gonna not make that public. Okay, now we're making progress. Okay, so the script is compiled and it has run, but the thread main panicked because it says secret not found, no such file or directly with the OS mirror. And this is actually hitting this line here. It is getting through to here, it's looking for the service account path, and it can't find the service account because I haven't put anything in that folder there. As I said, this is not the ideal way to, pass a credential service account JSON file into a sort of robust command line tool. Eventually I'll want to factor that out and make it into this path into some sort of thing that you can pass to the command line tool through an option. But for the time being, I'm just going to hard code it, put the service account.json file there so that I can keep going. Luckily, I already have a copy of the service account here in my other application. So I'm going to copy it from there into service account.json in my current directory, and I've got that service account.json. If you don't have the service account JSON and you want to do something similar, just look up service account Google Cloud, and there is a bunch of stuff that tells you how to create this JSON from the Google Cloud platform, basically. To reiterate, the service account is what allows me to access the sheet from the script, because this is a private sheet, I'm pretty sure, and the users who are added to the sheet are, how do I see the users that are added to a sheet? File settings? No. Share, I guess. Yeah. There are some proper Google accounts here, but I also add this email that is the email that's associated with the service account, which allows the script basically to access this sheet. And I've made it an editor because I want the script to be able to edit the sheet. Okay, so if I run this again, great. So it's run. So it doesn't actually do anything yet, but what it means is that this hub has been created, and if I wanted to check that that hub has been created, I could just print it. No. Okay, so it's giving me this error. It's telling me that this Sheets HTTPS connector doesn't implement debug. This is this hub variable. In order for something to be printed effectively in Rust, it needs to implement the debug trait. There's a bunch of different ways to print something in Rust. So if I just tried to print it using this syntax, it would say it doesn't implement the display trait. If I then try to print it with this other slightly different syntax, it says it doesn't implement the debug trait. So I can't really print that. That's fine. Let's just keep going with it. Now that we have the hub, and it is authenticated. Where is my hub? Here. Hub. Okay, this is a trait. Implementation. So let me go back to the example here. Okay, so we've got to this point. As the method needs a request, you would usually fill it with the desired information into the respective structure. Some parts shown here might not be applicable. Values shown here are possibly random and not representative. Rec value range. Hub values append, value input option. Okay. Values append. Okay, so I think what I want to do is use the spreadsheets method. It returns me a struct called spreadsheet methods, and RB equals hub spreadsheets. Let me do that, and let's see if I can print it. I'm not sure why it's called RB, but No, RB also doesn't implement debug. Sheets, copy to values. Okay, so the first thing I want to do is just get the values in it. I don't want to update them. I just want to get locally all of the values in the sheet. So I assume this is the method I returns a range of values from the sheet. Call them must specify the spreadsheet ID and add a range. Yes. So I'm going to say let current thread IDs. So just to make that a bit more concrete, what I'm trying to do is go to the sheet and basically get all of the values that are currently in here. I could, I guess, just get them once and then not have to go to the spreadsheet API, store them in the program memory, and use that as a kind of internal reference to check against the EdStem posts that I'm going to query, but I don't think I want to do that just because the sheet is volatile. I'm not trying to optimize on the requests to the sheet so much as I'm just trying to get it to work, and then I could think about these optimizations later. So I am going to use the thread ID is going to use get values get was what it was called. Values get. Expected 2 arguments, very handy. The 2 arguments are the spreadsheet ID and the range. And then these other ones are optional arguments because you can see that they... Oh no, sorry, this is where I'm looking. Spreadsheet ID and the range is what I need to pass in. So for the spreadsheet ID, I'm going to add it to here. My args, and the spreadsheet ID in my case is just this ID here. Struct args has no field called spreadsheet ID because I need to add it also to here. And this is a similar thing. I don't want to make it a reference. I'm just going to put it on the heap. I think I may have said stack before, but I meant heap. And then values get here. So values get here expects an @ string, so that expects a reference to a string, a pointer to a string. So I'm going to pass the pointer to args dot spreadsheet ID. So it's still missing one argument. The other argument is a range, which is also a reference to a string. The range that I want here is I'm making an assumption here that the range format of this string is going to be the same as the range format in Google Sheets, given it's a Google Sheets API. So it's something like A146 or A2. It would be. Let me actually write this in here. Might just be a bit better. So it's going to be something like A1 is a cell reference in Google Sheet, and that corresponds to the cell A1. You could also do the range A1 to A100, which means all cells from A to A100, or I could do something like A1 to E100, and that gets the kind of whole range of A1 to E100. So it would be this whole range here. The range that I want in my case